So these are basically just like real short. If you have slides, that's fine, but you don't need them. You can show a GitHub README. You can just run through a demo, or you can just talk about something. Just low pressure, talk about a thing that you happen to think is cool. And it doesn't even have to be like just Puppet related. So it can be somewhere in the ecosystem. It can even just be something vaguely related to an idea that somebody gave you while we were talking today. Looks like we have mostly uh, Raphael and John O'Connor who've submitted some talks, and we've also got a submission from Dimitri. These all look really good. Um, let's get started with Raphael. He's going to talk about certificate renewal, and then also a quick talk about some catalog diff stuff that he's working on.
So this is a short talk about Puppet certificate renewal. So if you've used Puppet for some time, if you've used it for 5 years or more, you know that at some point the default is that certificates and the CA certificate in particular expire after 5 years. You'll find yourself at some point with a CA certificate that has expired. What are the options to solve this? Well, you could create a new CA key pair. That's what we used to do in the past. And the problem with this is that you need to re-sign all your nodes with the new key pair. And that's problematic. That's a lot of work. So in the past, for example, we used mCollective for this, and then we found out that mCollective used the same CA, and hey, we were in trouble. So another thing you can do is create a new CA certificate from the same key pair, which helps because the agents are still signed by the key pair. So the agents will keep working. The only thing you need to do is deploy the new CA certificate before it expires. You can actually automate this new CA certificate deployment using Puppet itself. And eventually you could actually automate the agent's certificate deployment, so renewing the certificate. The most important thing is to think about it before it happens. You need to plan ahead. Know that your CA certificate is going to expire after 5 years by default unless you change this, and don't wait for the last minute to find a solution to renew it. There is a module, I was informed last week that it actually doesn't work with Puppet 6 anymore, so I don't know what are the options. I don't know if someone in Puppet knows what needs to be done, but this module allows to regenerate the CA certificate from the same key, which works most of the time unless your key has been generated so long ago that it's too weak and you start having problems with OpenSSL libraries that refuse to work with weak keys. It's been happening to me recently. But once you renew your CA certificate, then you have a problem with the agents because the agents were generated and signed by the CA certificate. They have a copy of the CA certificate, so they need a new version of the CA certificate before it expires. So that's one thing. But also the thing is, if you renew the key, then your agent certificates will never expire. The reason is that they also have a 5-year lifetime. So if you renew the key, you need to renew the agent certificate, so they are never older than the CA. But if you renew the CA certificate, keeping the same keys, then your agent certificates are going to pass the 5 years age, and then you need to find a way to renew them as well, to rotate them essentially. So one first step is to use autosign. There's different ways of doing autosign. There's a bad way and a good way. The bad way is using autosign with wildcards. Just don't do it. This is a big security hole. The second way is autosign policy, where you can send a secret in your CSRs, and then this secret is going to be looked at in the Puppet CA, and the Puppet CA will decide using a script if it wants to sign your certificate or not. There's different ways of doing this. This reference here to Puppet autosign by Daniel Dryas, for example. And then there's a module that was created to manage Puppet certificates using Puppet itself. What it does is that it can allow you to renew Puppet certificates, to create and manage Puppet certificates. One thing though is if you want to renew Puppet certificates on the agents automatically, you need to remove the certificates from the CA before you can renew it because the name doesn't change. Fortunately, this can actually be done since the Puppet CA has its own HTTP API, which is the Puppet server API. And so in auth.conf, you can add a rule. And we added this rule, which makes it so that the Puppet CA certificate deletion is allowed for the cert name itself. I don't think it's a problem security-wise because it means that nobody can remove the certificates except the agents themselves. So an agent has the right to remove its own certificate and just removes itself from Puppet, which is fine. Not from Puppet, but from the CA. Once this is done, then an agent can trigger the removal from the Puppet CA and generate a new certificate, which will be signed using the autosign approach. The problem, though, is you need to have the CSR attributes, the YAML file, which is necessary for the autosign approach, which contains some kind of secret that the Puppet CA will use to decide to sign the certificate. And this secret I don't want to store on the agent because it's some kind of PSK that has admin rights, essentially, because if you have it, you could get any certificate signed. What we wanted is to have a unique token per machine that would allow them to recreate their certificate without giving in an admin password, essentially. What we did is that we used a hashing function that contains the PSK plus some kind of other information that we don't want to change between renewals, such as the certificate name, for example. So if I take the PSK and the cert name and I do a hash from this, it's not possible to find the PSK back from this hash, and it's not possible to do anything else than using this cert name for the renewal. Why? Because on the Puppet CA site, the autosign script will generate the same digest, the same hash from the PSK that it knows about, and the cert name. The result is that if you have this hash, you can only recreate a certificate, you can only request a certificate for the given cert name because the autosign script takes the cert name from the name of the certificate that is sent. So it's not possible to create a certificate for another cert name using that secret. Now we can throw in more certificate extensions. For example, we use the PP role for classification. Could you talk on this actually? A PP role for classification, PP environment for setting up the environment. So if we put this in the hash, actually you can only renew the certificate with that secret for the same cert name, same role, and same environment. That's pretty restricted. We can couple this actually with fact provisioning, trusted fact provisioning. So these extensions in the certificate can be used to provision the machines. That's a side thing kind of, but it prevents us from using an ENC or HARA or site.db to provision the machine. So if we put everything together, we have the CSR attributes.yaml on the machines that contain this token, which is generated from a hash from the PSK plus the cert name plus the role plus the environment. And then in the code, we have a Puppet certificate a resource for the cert name that ensures it's valid. There's a wait for cert to wait when it's renewing it. There's a clean parameter to clean it from the Puppet CA using the Puppet CA HTTP API. And there's a renewal grace period, in this case 20, which is in days, which says that if it detects during a Puppet run that the certificate will expire in 20 days, it's just a saved value, in 20 days, then it cleans the certificate, cleans it from the Puppet CA, regenerates a new one, and by the end of the run, you have a brand new certificate that is signed by the CA to send the report back. This could actually allow to have an approach like Let's Encrypt in a way. So that's it. Goal is achieved, and we could actually, like I said, think of lowering the lifetime for the certificates to like 3 months, for example. I'm done. Thank you.
All right. Do you want to transition directly into doing the impact analysis talk rather than juggling presenters?
All right, I'll do that. This will not be as prepared. There we go. I'll base this on a blog post because I haven't prepared slides. Catalog diff. So Puppet Catalog diff is actually a tool that was created by Ari Piener years ago. Ari Piener, for those who don't know him, is the person who created HIRA and M Collective and really, really cool development in the Puppet community. So he created this tool some eight years ago, something like this, and then it was adopted by Zach at Puppet, and not a lot of people used it. For years, I've been using it on our stack, and recently we adopted it to kind of renew it, remove some old stuff from it. What does this do? This is a tool that can diff code between two Puppet environments. So in short, what you can do is, this is actually not what I wanted, more like this one. In short, what you can do is that you can take two Puppet environments and run Puppet catalog diff either between two catalogs or two Puppet masters and environments. And what it will do is that it will take the machines from each environment, if you make it point to the Puppet DB, and it will compile the catalogs on each environment for each machine, and then compare the two catalogs and give you a diff what has changed between the two catalogs. So this is typically useful when you want to test which machines will be impacted by a change between two environments, or if you want to change, if you want to see how a change in Puppet versions will impact you, you can try two Puppet stacks, Puppet 5 and Puppet 6, and compile the catalogs on both sides and see what diff you get. One thing you can do as well to make it a bit faster. Well, one thing first is that in order for this to work, the certificate that is used by your catalog diff, you need to generate a certificate, needs to be allowed to to compile your catalogs. And this can be problematic because it's not the default. By default, only a certain name can only get a catalog for its own name. So you need to add some kind of name, some kind of rule in oath.conf, again, oath.conf, to allow a specific access to this. So typically what we do is that we have the name of the certificate can access and retrieve its own catalog, and then we have typically a static certificate name that can also retrieve it, and we use it for catalog diff, or even better, use a certificate extension with the PP authorization extension, for example, set to catalog. This is what we do now, because we generate new certificates every time using autosign, and this way, this certificates have this extension, so we know it's allowed to get the catalog. And then when you do the comparison, you can also use PuppetDB to get the nodes that will be diffed, and you compare between two environments. So here, one Puppet master with an environment, and the second Puppet master with another environment. And the result is the diff between the two. For performance reason, you can also get the old catalog from PuppetDB in cache. This is a recent development. So instead of compiling the first environment, it will get the catalogs from the PuppetDB, which most of the time works because when you're doing a feature request, a new feature branch, usually you're merging into the environment where the machines are running most of the time, so you can get the catalog. I'll just switch to the end because this is just a lightning talk, so there's not much time. To show you the catalog diff viewer, which is a tool that I created a few years ago to view the results of these runs. And there's a demo that can be tried here, and it looks like this. So this is the kind of diff you can have, where you see for each node what was changed, the diff for each, and you actually can sort out things. You see here, if I put a little star on things, it appears in the column here. And if several nodes have the same change, the interface will show you that all these nodes have the same change. So I'm using stars to mark things that I need to look into a little bit more. So that's it. The project is obviously open source, and we welcome contributions to it. And I have some blog posts on dev.to on how to integrate this into GitLab to have automatic impact analysis on merge requests.
Yeah. Okay. So I am John O'Connor. I've been with Puppet just 5 years, and in the last year I've been working in the dev services team, more specifically with the development infrastructure operations team, which provides the tooling, processes, and engineering infrastructure needed to build, test, and ship our products at will. And a number of years ago, we had a blog post on a fairly common concept of dog food in your own product. And we made a radical decision a number of years ago to start very actively dog fooding all of our products internally within the engineering systems, which allowed us to sort of directly enter into the software delivery lifecycle by deploying the artifact of every sprint into production. That is every single sprint for each production. And yes, you did read that right. The infrastructure that Puppet engineering teams need to do their job is managed by the code they completed in the previous sprint. And as I mentioned, it's the complete internal engineering infrastructure. One of the important things about this that we've discovered it, and I'll share a number of points about it, is that it's not a replacement for teams doing their individual QA. And we have at times had issues with some sprints where teams have thrown something directly over without doing the QA. But again, this has helped enforce very good discipline with that. Yeah, I'm just showing the first slide again, which is dog fooding our products. And it's really just what I've said to you already, that we made this decision a number of years ago. There is incidentally a blog post, which I will post in the Slack channel afterwards, about this very subject. But we're customer zero for Bolt, CD for PE, IA content, LiDAR, and I'm not sure if it's there, but we have Relay, PE, Puppet Enterprise, PDK, Remediate, Visual Studio Code, Wash. So basically all of our products are passed through. And it establishes Puppet's developer services team as the first customer for Puppet's products in order to provide real-world feedback to product teams whenever possible. Because we have found, our experience has shown that no matter how well we put together our test rigs, and we've done some great automation in this area, there are always deployment kinks that come up that can show serious issues. We have trapped a number of P1 serious issues in this methodology before they've got out to the customer, so that represents huge value to us as a company. It also means the product teams receive regular feedback on products adopted by dev services workflows, including deployment issues, which don't often get tested in test rigs. The footprint of this initiative scales constantly as our product portfolio grows. For example, Relay is our latest candidate for this. And we are well able to, as a dev services team, consume our products and understand internally what is going on with the new products. So I'm just going to open for questions at this stage before I transition into the next part of the presentation.
And one more quick question. What is the most exciting or terrifying or interesting thing that you all have found with the Customer Zero effort? Like the biggest bug.
You would probably need to talk to Gene Liverman, who does all of this work for us. But there have been, I think when we were updating the version of Ruby, not Ruby, Java recently in Puppet Enterprise, we discovered quite a few scaling issues with it, which led to us having to choose very carefully the compile time parameters for it. That's one that just does stick out recently as quite a useful one before we did the beta deployment. And yes, it has been meant as well too. Ben has just said he's the boots on the ground for Customer Zero, which is very true. but it also means that he's become pretty well a subject matter expert on deploying most of Puppet's products. Okay, I'm going to transition very quickly into my next talk, which is on it's handling Windows reboots in Packer. We have found Packer an extremely useful tool internally for building our images for our dev test environments. I've also had feedback from our professional services that Puppet would recommend that you use Packer as a deployment tool for pre-building commonly used images in production. You can use Puppet to fully deploy a new image or to provision a new image, but if you're scaling out multiple images, it is much better to have pre-built images ready for deployment in production that are nearly there. So you deploy a pre-built image and then use Puppet to do the final configuration for it. And within this, it's quite useful to be able to use Puppet as a tool within the Packer build. One of the issues you experience with that is particular to the Windows image building process is that you may need to do an indeterminate number of reboots during your configuration. And Packer as a tool doesn't immediately lend itself to that because it's very much a descriptive language where it says, do a provisioning script. You might want to do a reboot, but it's just one reboot. And then you may want to do additional provisioning with that same script. And Puppet is a tool that, for example, can do multiple package installs. And this would be the case, for example, with SQL Server, where you need to do an install. You need to install SQL Server, and then you might need to install another package that's dependent on it. So it's quite possible that you might need to do multiple reboots within your Puppet deployment. The other use case for this is Windows Update, and particularly for the earlier versions of Windows where you need multiple cycles of reboot Windows Update before you do your before you have your image fully prepared. Matt Rocks is probably the state-of-the-art blogger on doing Packer images, and he has done some extremely good work in doing all the Windows Update in what we call the pre-initialization phase. But what I was able to do was take that a stage further recently and take some of the excellent steps he's done and actually integrate them directly into the Packer build process. And this is really just a very short summary of the technique. I'm going to show how we do it. And what you do, firstly, I apologize here for the very rudimentary scheduled tasks command here. The reason for that is that up to recently, we were still building Windows 2008 R2 images, which only had PowerShell 2. Later versions of PowerShell give you PowerShell primitives that are commandlets that actually allow you to create scheduled tasks much easier than this. And given that this was a lightning talk, I put it together very quickly this morning. So what you do is you use a scheduled task to create an on-startup task, which then runs a script, which is your actual provisioning script. You then disable WinRM at boot. So the next time you restart your machine that you're doing the Packer build on, it will not bring up WinRM. That has the effect of causing it to go silent for Packer purposes. You then execute within the Packer script a Windows restart with a decently timed Windows timeout. This example, I've just set it to 30 minutes. And what happens is then your provisioning script comes up, or your background script that was set as the scheduled task then starts up and does its work, which I'm assuming in this case, say it's a Puppet configuration script. And that script is set to do multiple reboots, as many as you want, until you've completed it. So that can reboot multiple times, but Packer will not detect that it's up again because it's waiting for WinRM to come up. When the task completes, you then have a final stage where you do a set service WinRM automatically start up on the next reboot. You then delete the scheduled task and reboot your system. And the next time it reboots, it will then come up and Packer will then be able to detect that it started. One other thing that I haven't shown here is that what I've done then is that I've made sure that the log is collected in a log file on the system, and my next task within Packer is to print out that log so you actually get a printout of what happened when it was off air to Packer. One of the things we were able to do with this was to bring the Windows Update phase, to use this methodology for the Windows Up phase, which then meant that the boot initialization phase became very, very short, which was really just some initial driver initialization sequences. And it meant that we got fairly early detection if the boot phase failed. So that's quite a technical talk about a technique. I'm more than willing, if anybody wants to prompt me on the Slack channel, to actually share you the code and to talk about this in detail, because we have found this very useful to us for our Windows image building. Any questions on it?
Are you still there, John?
I am, yes. I've seen the question. I mentioned a Windows example, but are there other applications? I assume you mean, will this work on other Linux platforms, for example? The answer to that is I don't know, but I see no reason why it shouldn't. But I would imagine with Linux, you would be using the SSH transport layer. So you should be able to do it, but the best thing to do is to try, and I would be quite happy with some folks internally who are working more on the Linux image sides to try it out. But by all means, contact me again.
We also had a pretty cool suggestion earlier, saying that it would be neat if we would sort of like periodically publish lessons that we've learned from our customer zero effort. Like maybe get some blog posts up from Gene or the like. I know he's done a couple. He did one about encrypting secrets and things like that, but it might be an interesting story.
Yes, I think so, or even a longer talk at one of the public camps would be. I'll certainly feed that back to Gene because he is a very keen blogger.
Okay, and then I think our final talk for the day is going to be Dimitri. He's going to talk about a really cool tool that we use internally for standing up like demo and classroom environments.
So what I wanted to show you is how we currently deploy our learning and demo environments inside Puppet. So previously it was kind of a do-it-yourself project for everybody who wanted to create a demo environment for customers. But since about a year, we have centralized our efforts and we've created a system called Hydra, which automatically spins up a demo or a learning environment for us that uses Terraform and the public cloud, at the moment AWS. The interesting thing about Hydra is that, just like John mentioned, it has helped us found a lot of interesting pre-release issues with products before they were released, because all our customer-facing folks were keen to basically create demo environments of products even before they were released, just to see how they work and play around with them. So that's one of the interesting side effects. And the other is that we have expanded Hydra in the meantime to allow for different stacks to be spun up. So it's not one size fits all demo environment. You can choose when you start Hydra, you can choose what kind of demo environment or learning environment you want to deploy. So we now have a standard environment or specific workshop environments like the CD4PE workshops or the Bolt workshops. So what I wanted to show you is basically how the Hydra interaction goes. If you wanted to stay and join our scavenger hunt, you will be actually using an environment which has been created and deployed by Hydra. So you will see how the end result of that deployment looks like. So I will be happy to answer any questions or share more info if you are interested. Thanks, and sorry for the sharing disaster.
All these things happen.
Yeah.
Sorry, go ahead.
Just from myself, I probably missed this internally, but why Hydra? No relation to the villain in the Marvel comics?
Yeah, so this lightning talk was unprepared, so I don't know the answer to that question. But I will dig that up. That has been chosen like in the beginning of the development, and it has a nice logo of this Hydra multi-headed beast. I think it has been chosen because it can do a lot of things, right?
No, it is connected to the Marvel comics. There's a kind of internal theme for Puppet products that use Marvel characters in their names.
Okay, you see? So there are many reasons.
We like naming things.
I have a question for you, Dimitri. Do you know if there are plans to port it to using Relay or anything like that?
So my personal goal is to try and move that to Relay as soon as we can. It needs some re-engineering for that because now it has a quite bespoke deployment architecture. For example, it uses well, as I said, it uses Terraform to deploy the stack itself, and then it uses some mechanisms to basically do the accounting of the environments. So it keeps track of which environments are still running. It can schedule when you create an environment, you can say how many days you need it, and then it will automatically auto-expire them after so many days. So basically, it has its own state in the cloud, which needs to be preserved. So when if we can re-engineer that easily, then I think we'll need to make an effort to bring that to Relay. Absolutely.